Welcome back to class. Today we are going to be looking at a very important topic in the chemistry, which is general overview of the topic organic chemistry. Organic chemistry. Now, as you can see, what we have here are just like some of the things you may see in organic chemistry. But what is actually the basics of this organic chemistry? That's what we are. That's why we are here. I'm going to be explaining this topic once and for all. So you can see the class is just like your notes and a tutor explaining the note to you, or your textbook. The tutor is explaining the textbook for you. So the thing you have to do now is to ensure you don't distract yourself. Don't be absent-minded. Don't distract yourself by any means. Ensure you watch this video from the beginning to the end in a very good manner. Focus on this class. Just create time. Ensure as you are watching, don't let anything to distract you. I bet you are going to gain a lot from this class because we'll be explaining something very important here. After this class, you are going to be something like very familiar with most of the terms used in organic chemistry and what the organic chemistry is actually all about. So all you have to do now is just to ensure you don't distract yourself, and also try and like this video, and also if you have not subscribed to our channel, please try and do so. It helps us a lot. So let's look at what we have today. Now, we said the topic is organic chemistry. Now the first thing is, what is the meaning of organic chemistry? When we are saying organic chemistry, chemistry can be organic, inorganic. Now chemistry just something like study of reaction that matters do undergoes, or changes that matters do undergoes. That's why it brought us to like all those changes matter do undergoes. We say we have chemical change, we have physical change. That were the first aspect or basis of general chemistry as a whole. Now there's another part of chemistry that we call the organic chemistry. Now what is the meaning of organic chemistry? Most of the things that do come to our mind is people say are natural. No. Organic chemistry have its own something like definition, and it is the study. Organic chemistry is just the study of organic compounds. When you are studying organic compounds, like reaction they do undergoes, they are also like how they do change, how they are, and the rest. That is what we call organic chemistry, the study of organic compounds. Now, what is the meaning of organic compounds? Now, organic compound definition do differs from author. We have different authors in chemistry. One thing about chemistry is that so many authors do something like conflict with each other in terms of their languages and definition in some aspects of this chemistry. Remember periodic tables, so many authors worked on that periodic table and people are still working on it now. So there are some things, remember geodatics, atomic theory, all those they'll say correction to this theory, because some people will still come and fault it. So different authors have their different definition for organic compound. But simply, we can just say organic compound is a compound that something like has a carbon and a hydrogen, something like bonded together, or carbon-carbon bond chains. Although there are some other atoms that can also associate with these chains, which can be all those nitrogen, oxygen, phosphorus, sulfur, and the rest. They can also come on board here. So the major carbon hydrogen, the major compound that is comprised of carbon and hydrogen is the one they called hydrocarbon. The carbon is a compound. Carbon is a compound that is composed mainly of carbon and hydrogen, and the organic compound is still just like that. So we have other something like atoms that will now elements that will now something like be added. When you get to something like alcohol, you see oxygen there in their functional group. We get to carbohydrate, carboxylic acid, this star, you see that oxygen is now coming on board. So that's why we would not just say carbon and hydrogen only for organic compound as a whole. Then Some people do say is people do define it as the study organic compounds are just compound of carbon and maybe carbon and other atoms, maybe carbon and its compound, but exertion from most oxide of carbon like carbon 4 oxide, carbon 2 oxide, carbon, all those oxide of carbon, a section from those ones like carbon 4 oxide. Now you cannot say that one is organic chemistry. Now, carbon has the ability. Now, let's enter mainly. Let's enter the topic now. Carbon have the ability. You can research more on that definition of organic compound. Although just know that it's compound of carbon and the hydrogen atom and any other atom, but not most oxide of carbons like carbon 4 oxide, carbon 2 oxide, and the rest.
You see, in chemistry, many authors consider an organic compound to be any chemical compound that contains carbon, hydrogen, or carbon-carbon bonds, although the definition of organic versus inorganic vary from author to authors. So that's how chemistry is. So just try and get that. But mainly, carbon and carbohydrate, although we still have other things like carbon and chlorine, like this tetrachloride that you're seeing there now.
Then carbon has the ability to catenate. That is the first thing you need to know in this topic. Carbon has the ability, not hydrogen. Carbon has the ability to catenate. Now, what is the meaning of catenate? Carbon has the ability to form a continuous chain with other carbon atoms. So because of this, many or numerous organic compound is now being known. That is something like one of the compound I know that it can catenate very well. Catenation is the ability of a compound to form chain with its safe atom. For example, now you see like 10 carbons forming attached, maybe being attached to each other. We'll be seeing it as we are going. You'll be seeing what I'm saying. So the ability for carbon to form a chain or a carbon skeleton, call it carbon skeleton, is called catenation. That's what we call that. So take note of that. It's very, very important. Now, how do we classify these organic compounds? How do we classify organic compounds? Now, listen to this. Organic compounds can be classified mainly let's say in two ways. Organic compound can be classified based on the structure of that organic compound carbon skeleton, or you can also classify it based on functional group. You can classify it based on the structure of their carbon skeleton or based on what? Their functional group. Now, what's the meaning of functional group? We'll get there and you'll see it. Now, how do we classify? If you want to classify organic compound based on the structure of carbon skeleton, that is how this carbon skeleton. Remember, I told you carbon can form what we call carbon skeleton or carbon chain. Remember the meaning of chain, when you have one thing being attached to each other to form a very long or to form a line or something like that. Maybe you have one thing, another thing, the same to be attached, the same to be attached again, the same to be attached again. You see, you start forming a line. That's what we call a chain. Then how do we classify organic compound based on carbon skeleton? So we classify mainly in these 4 ways that you are seeing now, but I can classify it mainly 2 ways, but I don't want you to be confused. That's why I'm very careful of how I'm taking this topic, so that you will not be confused at the end of the day. Now listen to this. If you want to classify based on the structure of carbon skeleton, we first of all group it into 2. They can be called, we have some that are called cyclic compound. Then we have another one that is called acyclic compound. Now, I don't know if you have ever seen a straight line before, or a line that have a branch, but it's still maybe straight, they will not have side branch. Let's say a road, you have a road, the road has a branch. Like you have major road, we have street attached to that road, or something like that. Then I don't know if you have seen another thing before, a roundabout or a road that is a form of a cycle. So anything that is in the form of straight line or is having any branch at all, we call it
a cyclic compound. What do I call it? A cyclic compound. Anything in form of what? A straight line, any compound in form of a straight chain or branch chain. We have branches or just a straight chain, we call them acyclic compounds.
Then the one that is a form of a cycle or a closed loop or a closed ring, they call it, ring. Anything that look like a ring that is closed, this called cyclic compound. That's what we call those ones. Now, those are cyclic, and cyclic compound can be grouped into four as follows. Now, the first one is called aliphatic compound. That's what we call it. Aliphatic compound. Aliphatic compound is from those cyclic and acyclic, any of them. Now, aliphatic compound is an acyclic compound, because what is the meaning of an aliphatic compound? We'll get there, because we're still going to explain aliphatic compound. Let me just explain. Aliphatic compound something like a compound that has or that is composed of straight or branch chain of carbon skeleton. It's comprised of what? Straight or what? Branch chain of carbon skeleton. That is the meaning of aliphatic compound. That's why we said it's also or a cyclic compound. So it has a straight or branch chain carbon atom. They also have alicyclic compound. Alicyclic compound. Now, those aliphatic compound that is a form of a closed ring is what we call alicyclic compound. They are those aliphatic compound that is a form of closed ring. Remember, aliphatic is a form of a straight line or branch chain. A straight chain or branch chain carbon atom, we call it aliphatic or acyclic. I've already explained that. Then alicyclic is a type of organic compound that is from non-cyclic compounds, because this one will form a closed ring or a closed chain. This one is not a straight line or branch chain. This one will form a closed chain compound. Then aromatic compound. Now, aromatic compound have a very unique definition. Then, because we have two types of aromatic compound.
Because we have the benzenoid aromatic compounds and the non-benzenoid aromatic compounds. Now, the one that has at least one benzene ring called the benzenoid aromatic compounds. The one that don't have any benzene ring but still have aromatic character are called non-benzenoid aromatic compounds. So maybe later I'll show you guys how to get the aromatic compounds, aromatic character of a particular compound. But before a compound can be called aromatic compound, it must be a cyclic compound. Remember, a cyclic compound is a type of compound that is in a closed chain of a carbon atom, while aliphatic or acyclic are in form of what? Straight or branch chain carbon atoms.
Then we also have heterocyclic compound. Now, these are compound that is a form of a closed chain. You will say that this one is cyclic. It is aromatic that don't have cyclic inside, and it's still a cyclic compound because it will still form a closed chain. So aliphatic are acyclic because they are in form of a straight or branch chain. Then alicyclic, aromatic, and heterocyclic are cyclic because they are a form of a closed ring. Take note of that. It's very, very important. When we're going deeper now, you will see what we are actually trying to explain here. Now, heterocyclic compound are compound that form a closed ring of carbon atom and any other atom inside this closed ring. Most of these atoms are oxygen, nitrogen, sulfur, etc. So if you have maybe alicyclic compound or aromatic compound that has any other atom inside, not as a branch, inside the closed ring of this carbon atom, we call it heterocyclic compound. Now, you will see the drawing of aliphatic, alicyclic, aromatic, heterocyclic. Maybe as you now see those drawings, that we explain this stuff better to you. Now, let's look at passing now. Generally, what is aliphatic compound? What is mean? If I ask you now, what is the meaning of aliphatic compound? What are you going to say? They are compound. It's comprised of what? Straight or branch chain carbon atom. Now, examples of aliphatic compound. Examples of aliphatic compound are the alkanes, and the alkynes. Now, alkanes, and alkynes are the examples of there are some of the examples of aliphatic compound, because alkanes, and alkynes are just something like they differs from each other based on the structure of their carbon skeleton. Alkane is saturated because it's comprised of carbon-carbon single bonds. Then alkenes is unsaturated because it has a carbon-carbon double bond, at least one carbon-carbon double bond. Then alkynes is unsaturated because it has at least one carbon-carbon triple bond. Then we have ETC because we also have another aliphatic compound or acyclic compounds that we be something like classified in terms of functional group now. We don't say this one is a cyclic because of this functional group. Remember, I told you guys that you can classify organic compound based on the what structure of their carbon skeleton or functional group. Now, this classification now is just based on structure of carbon. Okay, what our baby doing is we said this one is aliphatic. Why? Because of this structure of carbon skeleton. You say this one is acyclic. Why? Because of this structure of the carbon skeleton. Aromatic. Because of this structure of the carbon skeleton. Because this one is just based on structures. We will still look at other types, classes of organic compound or types of organic compound. Because okay, let me just call it class because we are classifying them. Class of organic compound because of the kind of functional group they are having. We'll now be having something like alcohols, alkanols, ethers, esters, and so on. Please take note of that. It's very, very important. So this one is just based on the structure of carbon skeleton. This one is aliphatic because it has straight chain. It has straight chain of carbon atom are cyclic. Okay, we'll explain those ones. Don't worry. Aliphatic, we said it has straight or branching carbon atom. We now said we now mentioned something like saturated, unsaturated. Now, saturation is something like we did get how a compound can be saturated or unsaturated because of something like the bond between their carbon-carbon skeletons. Now, any compounds or mainly any compounds that has let's say carbon-carbon single bonds throughout. There's no double bond. There's no carbon-carbon double. I'm talking about carbon. This bond I'm talking about is between carbon and carbon. That's anytime you hear carbon-carbon, it means bond between two carbon atoms. Between what? Two carbons atoms. Take note of that. So we say these compounds now are aliphatic because they have straight or branching carbon atoms. Now, we now said some of these three, they are called saturated aliphatic compounds, while others can be unsaturated aliphatic compound. What do you mean by something saturated? It means it has carbon-carbon single bond throughout. It does not possess multiple bonds. It has single bond between each carbon atom throughout. Then what do you mean by something is unsaturated? Because it has carbon-carbon multiple bonds throughout. It can be double bond, it can be triple bond. Take note of that. So remember we have pi bond and sigma bond. I hope you can still remember that. If a compound has single bond throughout, those single bonds are sigma bonds. If a compound has single bond and double bond, maybe double bond, one of these double bond being two bonds. One of those two bonds can be called sigma. The other one will be called pi bond. Single bond is always a sigma bond, but double bond will be sigma and pi bond. Triple bond will be one sigma and two pi bond. So that means for sigma and pi bond, although you don't have sigma and pi bond here, I'm just explaining all those bonds between because alkyne now we have triple bonds. That triple bond now will have one sigma bond and two pi bonds. Alkenes will have double bond. That double bond will be one sigma bond, one pi bond. Alkenes will have single bond throughout. That single bond will be sigma bond. Take note of that. It's very, very important. Now, what is the meaning of sigma bond? Sigma bond is formed by the head-to-head collinear overlap of atomic orbitals. It can be s orbital, it can be p orbital of atomic orbitals. Why pi bonds? What do you mean pi bond? Pi bonds are formed by the side-to-side lateral overlap of p orbitals. Lateral overlap of what? Lapping of what? P orbitals. Take note of that definition. Lateral overlapping of p orbitals form pi bond. Why head-to-head collinear overlapping of atomic orbitals form a sigma bond. Now, pi bond does not have free rotation, and you can see more than one pi bond between atoms. Sigma bond has free rotation, and sigma bond cannot be more than one between atoms. If bonds are more than one, the others are pi bonds. Only one of them will be sigma. If it's only just one there, that must be a sigma bond. So it's sigma bond first before you start having pi bond. Take note of that. So we will explain that later, maybe in order to, I just wish my speech just told me to explain that sigma bond and pi bond to you guys. You can go and something like also check about that. So we are doing classification, we are not doing bonds. So remember, alkane has is a type of aliphatic compound that possesses what? It possesses carbon single bonds and is saturated because of this carbon single bond. And it has a general molecular formula, or it has a general formula of CnH2n plus 2. This one will give us all the molecular formulas of the alkane series. Now, there's something called homologous series. Homologous series, we'll get there, don't worry. Now, in alkane series, we have formulas. Remember, we have called structural formula and molecular formula. Now, if you want to get the molecular formula now of the first member, that is first means number 1. Now, this n you are seeing here give the numbers. It's just an integer that give the number of what you'll be having in the alkane series. They are well numbered from 1 to maybe infinite. Although the more I've seen like 1 to 100. So we say number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 90. Maybe we get to 100 and other big higher alkanes. So n is just maybe a number starting from 1. Now when n is 1, we are going to have Cn H. Maybe we are going to have C times, that's n is 1. I'll put anywhere C and you put 1. 2 times 1, 2 plus 1, 4. Although I will explain this one when I get to homologous series. Don't worry about that. So this is the general molecular formula of alkane series. We use one to form the alkanes. When n is 1, we are going to have what we call methane. If n is 2, we have ethane. If n is 3, we have propane. If n is 4, we have butane. If n is 5, we have pentane. If n is 6, we have hexane. If n is 7, we have heptane. If n is 8, we have octane. If n is 9, we have nonane. If n is 10, we have decane. If n is 11, we have others, and so on till 100. I'll teach you how to get their names when I get to homologous series. Now let's go to alkanes. Alkanes are unsaturated and hydrocarbons or organic compounds that comprises of at least one carbon-carbon double bond. Carbon-carbon double bond. Now, alkane. Okay, let me just explain this more better. Now, alkanes are something like a sp2 hybridize. sp2 hybridize. Take note of that. Okay, that is methane. That is 18. Not all alkanes safe, because there are some alkanes you see sp3, sp2, because some will be having a steric number that is let's say 4. So sorry about that. So that is 18. 18 is the simplest member of alkanes. Take note of that. 18 is just like as I was mentioning methane 18 before. So the only difference between this and this is just that you remove this A and put it N. That is, instead of to be saying aid now, you be saying in. That is the only thing. So we also have something like we're supposed to have methanes, but because of the complexity of that compound, we don't use to add it. So N here for alkanes do start from 2, not 1. So when N is 2, we have what we call 18. We just that is simplest member of the alkane series. The same thing with this. When N do start from 2 here, but for alkane N do start from 1. But for alkenes and alkynes, N do start from 2. We don't have 8. So this one will be 18 when N is 2, while this one will be 18 when N is 2. So take note of that. But this one will start from 1, which is methane, before you get to 18. But this one starts from 2, which is 18. So I start from 2, which is 18. So the simplest member of the alkane series, is the what is called methane molecule, which is this. We got the methane here. And it's CH4. I already told you how to get this number 1, the first one. That's just the number 1. You put 1 in where you are CN, you have CH4. Or this is the structural formula. The C is at the center, we have hydrogen surrounding it. Why is C at the center? Because carbon is the central atom there. Carbon is the central atom, or carbon is the backbone of the of this CH4 you are seeing here. So don't go and write H, you put C here, you put D. This H is bonded to this carbon. Take note of that. It's very, very important. Other compounds are mainly bonded to this carbon here. So carbon cannot, something like say carbon is no. It's either carbon is bonded to carbon or other atom be bonded to carbon. So carbon is the major element in this organic compound. Then we have methane as an example of the alkane series. You said in the case we have methane. We also have we don't have methane because alkanes do start from 2, so that we have 18s. But there's one they called methylene. I'll show you that later. Methylene. Methylene is just a complex compound that we do see inside maybe a straight chain of all these hydrocarbons. So I will show you or organic compound. If I just see one, I will show you. Look at the one called methylene, because they can ask you in exam. They say how many methylene can you see inside this structure. So you have to count it and tell them. Methylene is just something that has a CH2, but have a 2 double bond attached, exception from that CH2. So let's look at other things now from this aliphatic compound. Remember, aliphatic compound are the alkanes, alkynes, etc. As far as it has a straight or branch carbon atom, is aliphatic. So let's look at others now to see. So if I say let me be explaining only the aliphatic compound, we may not live here. We explain and explain and explain and explain. Let's also, because we have a lot of things to explain here, so let's explain others. So please just try and follow up. Remember, we have classification based on structure of carbon skeleton and what functional group. Based on carbon skeleton, we can have some forming a cycle, or some will forming a straight line or branched, having a branch. Those that are forming a cycle, we call them cyclic, which can be alicyclic, aromatic, or heterocyclic. Then those that are forming a straight line, we call them aliphatic, which can something like be also called acyclic. So let's look at some examples now of this aliphatic as well. We are still giving an example. We have another one, number 4, butane. When N is 4, like C4. When N is 4, we have butane. Some people can also write this one. They'll go and put C2H5, they'll bracket it and put 2 at the end. We'll now use that 2 to put the bracket. Will now be 2 times 5, 10, 2 times 2, 4. Also take note of that in condensed form. So take note of that. So this is the molecular formula of butane, and this is the structural formula of butane. Now, how am I going to write this? The first thing, we have 4 carbon here. So ensure, because carbon can catenate, ensure you just first of all bond all the 4 carbons to each other. We don't have C bonded to each other. Then you now start sharing hydrogen to them. Now, ensure a carbon must have 4 bonds attached to it. Very important. If a carbon is inside this place and the bond attached to this carbon is not 4, it means the structure is not correct or something is missing. You must put the bond there. Now listen to this. If alkane loses just 1 hydrogen atom, we'll call that alkane alkyl. That's what we'll now be calling it, alkyl. For example, now if you remove 1 hydrogen atom from this place, this one become butyl. There's a class of organic compound that is called alkyls. They are formed, not alkynes, no, alkyls. 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 You can browse to see it. Alkyls. They are formed when an alkane loses just 1 hydrogen atom. If any alkane loses 1 hydrogen atom, it will be called Kai. Take note of that. It's very, very important. So this butane is therefore write C into 4 places. We have C. Then bond all the C to each other. Then start bonding the hydrogen to it. So we have one hydrogen. Why is this one having the 1, 2, 3 hydrogen atom? Even the first one we did before that, methane, was having 4 hydrogen atom. But this one now inside this place is having 3. This one is having 2. This one is having 2. This one is having 3. Why? Because that is the structure. Check very well now. This carbon is having how many bonds? 1, 2, 3, 4 bonds attached to it. Check this one. 1, 2, 3. As far as 4 bonds, stop adding hydrogen. Don't go add another one. See, this one is having, this one must have 3. No. Just check how many bonds attached to this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4 bond attached to each of the carbons. Please take note of that. It's very, very important. So you can also write it this way. You can also write butane this way. You're also free. To write it this way. You see 3. We have C 1, 2, 3 hydrogen. Brand C2. We have C 2 hydrogen. Branch C2. We have 2 hydrogen here. Then branch C3. We have 1, 2, 3 hydrogen. So you can see it. Or look at another example. 2-methyl. Remember I told you about the alkyls group. This methyl now is coming from alkyl, which is methyl. It's coming from alkyl. So methyl, this one is 2-methyl propane. I'm going to show you how this one is 2-methyl propane in another video. Maybe necessarily not this video. How to name organic compound. Though we have done it before. Just search how to name organic compound or nomenclature in organic chemistry by the Best Academy. You see it there. Although I may do a review class just like this, which I'll teach you just with your notes. You'll be seeing it word to word. So this is 2-methyl propane. You can see C4H10. It's still C4H10. C4H10. How come? This one is C4H10, this one is C4H10. It's possible in organic chemistry. And this case now, in which this one has butane as a name, so it has 2-methyl propane. They are not the same organic compound, but they have the same molecular formula. But look at their structures. Look at the structure of this one. We have C. Because the major name, the parent name, or the main name is propane. Remember, propane has 3 carbon atoms. Number 3, which is C. That is propane. So you just bond hydrogen first to this one. 1, 2, 3. Then this one is 2-methyl. That means there is a methyl molecule attached to the number 2 carbon. So you just count either 1, 2 from here or 1, 2 carbon from here. So the first you do here, if you ever write, the main name is the last one. That is the main name, the last one, which is propane. If you ever write 3 carbon atoms, 1, 2, 3 carbon atoms. Leave hydrogen first. Hydrogen is not a problem. There are some compounds they will not put hydrogen. Because the carbon, the structure of the carbon skeleton is the meeting, not hydrogen skeleton or hydrogen. Hydrogen will not even form a skeleton. So the carbon skeleton is the major thing. So we have 2-methyl propane. Propane is the major name. So if you ever write propane is number 3. I'll teach you that one, how to get those names in your memory in homologous series. So if you ever write 3, carbon atom 1, 2, 3, then make sure you bond all of them to each other first. Then we have 2-methyl again. Methyl is they call it substituent in nomenclature in organic chemistry. So you can go and check that class we did. We have 2-methyl propane. So the number 2 means it is at the 2nd carbon atom. That is the meaning. It's present at the 2nd carbon atom. So just write, go and place a carbon atom again at the number 2 carbon atom. So we have 1, 2. So you attach another carbon atom to this place. Or you just count from this end, 1, 2, attach another carbon atom to this place again. So after that, you now share the hydrogen atom to them. Ensure they have 4 bonds. Remember, this one is now only 1 hydrogen because it's having 4 bonds already. 1, 2, 3. Just add 1 hydrogen. 1, add 1 hydrogen, 1 hydrogen, 1 hydrogen. 1, add 1, add 1, add 1. 1, add 1, add 1, add 1. So this one is now 1, 2, 3. So this one is now 2. We have this one is methyl. Why is it methyl? Because we have CH3, 1, 2, 3 hydrogen. Remember, CH4 is methane. If it loses 1 hydrogen, if we remove 1 hydrogen from methane, it will become a methyl. That is all. If you have alkane, let's say propane, and you remove 1 hydrogen atom from that propane, automatically you will be calling it propyl. That's all. So I will show you how to name organic compound, or I've already done the class. You can go and search for it. You see it. Nomenclature in Organic Chemistry by the Best Academy. You can check it. So you can also write this one this way, which is C123, H just only one H, C123, CH3. Then look at this, C123, CH3 again. So this is 2-methyl. The compound name is propane because 1, 2, 3 atoms, that is propane. Then we also have ethene. Look at it, ethene. Ethene is from that alkenes. Look at it, C2. Remember I told you ethene is the simplest member of the alkene series, and it's the number 2 in that series. So that's why we have 2 here, C2. We have 2 carbon atoms, H4, 4 hydrogen atoms. So you can just therefore put 2 carbon atoms, 1, 2. Ensure you join the 2 with double bond. Remember I told you alkenes has at least 1 carbon-carbon double bond. So this one is ethene because it's having the we cannot call this one ethane again. It's not ethane, it's ethene because of this double bond there. Ane we have single bond, in we have double bond. So why is this one not having 2 carbon, 2 hydrogen, 2 hydrogen? Because the ane just now was having 3. Because check how many bonds is attached to this carbon. 1, 2, 3, 4 already. So there's no need of adding another hydrogen again. What about this one? 1, 2, 3, 4. It's attached to this one. 1, 2, 3, 4. So all these other bonds will take hydrogen. So we have H4. Remember from the general molecular formula of alkenes, CnH2n. So if it's 2 times 2 will be 4. That is 2. Or you can also write it like this: C2 double bond C2. You can also write it this way. Take note of that. Or you can decide to write it like this: H2 C double bond C H2. Because you want the bond to be between carbon. Be showing. This is the more something like a profiting way to write this stuff here. So another thing I would like to show you now is another example, which is ethyne. Ethyne is CnH2n-2. So if we have the number 2 carbon atom now, remember ethyne, alkynes and alkenes. Alkynes is different from alkynes, so take note of that. So if our stuff, what is it called, alkenes and alkynes, I started from number 2, so that's why I'm starting with number 2. I don't put 1 because there's no number 1 here. So I'm going to have alkynes. Look at it. So the first member there is ethynes. Ethyne. That's the first member there. Ethyne. So the trivial name of the alkenes, the trivial name or the guy name of the alkenes is olefins. That's the trivial name of the alkenes. Take note of that. It's also very, very important. So I will explain this when I get to homologous studies. I will also explain more of these alkenes, and alkynes. So ethyne is C2H2. Remember, alkynes we have at least 1 carbon triple, that is 3 bond. So in this double bond now, one is sigma, the other one is pi. This single bond are always sigma. So double bond will be 1 sigma, 1 pi. Take note too. So this one is triple bond now because it's from alkynes. So CC must be bonded with triple bond. Not all the carbons, so at least one carbon. 1 carbon triple bond, at least 1. It's not that you put triple bond in all the carbons. No. It's not like that. If you write the compound out, at least carbon we have 1 triple bond. That is carbon and carbon will have at least 1 triple bond between them. Take note of that. You cannot even put triple bond. You are going to put triple bond the other side. 1 carbon will have a 6 bond, which is forbidden. A carbon must have a maximum of 4. That is, it must have 4 bonds. So we judge one very well. How many bonds does this one have? 1, 2, 3, 4. Attached to this one only. How many does this one have? 1, 2, 3, 4. You can see it. 4 bonds. That's what we have for carbon. So you cannot even put double bond there. That's why we are attaching only 1 hydrogen to this and only 1 hydrogen to this. That's why, so that the bond will not be more than 4. And you still follow the general molecular formula for alkynes, or you also write it this way. But if you see a compound like this, let's say C, you have a bond here, you have a bond there. Okay, let me just for you this one. We have CH2. There's a bond there, there's a bond there. That compound is called methylene. That's what we call it. Methylene molecule. Or just write it like C. We have a bond here, we have a bond here, we have H here. Look at it. C, a bond there, H. This one is called methylene. They can ask you a question. They say, how many methylene group do we have inside this compound? So just one now, there's no methylene group here. You might know, because okay, you can even something like, say, if you rearrange this one, okay, this one is just double bond here. We have two bonds here, or one bond. This one is complex. Where you can call this one methylene. I don't think so, because you cannot rotate this double bond and come and put one on this other side. The best way to get this methylene molecule is from this. If you check now, if you check this one have 3 hydrogen, not methylene. This one have just 1 hydrogen, not methylene. This one have 3, not methylene. This one have 3, no methylene group here at all. Self. Let's check this one. This one, look, check this carbon. Check this one very well. We have H, bond. That's a methylene molecule. Check this one. Bond, H. That's another methylene molecule. So inside this butane now, we have 1, 2 methylene molecule inside this place. This one have 3 hydrogens, not the methylene. This one have 2. Yes, very good. We have bond here, we have bond here. This one is a very good way. Check this one. Check this particular one here. Check this one. Check this particular one. Then come and check this. If they are not the same, those 2 central carbon. After the first one, those 2 other carbon. Check if they are not like this. We have carbon, hydrogen, bond. The other one, carbon, hydrogen, bond. That's what we mean by methylene molecule. So let's